Imagine staring into the night sky and slowly realizing the darkness is not empty. It is layered, textured, and filled with ancient light that has been traveling for billions of years just to reach your eyes. For most of human history, the universe felt like a silent stage where stars burned and galaxies drifted without purpose. That quiet assumption began to change when our ability to observe the cosmos expanded beyond anything we had ever built before. When humanity's most powerful space telescope unfolded its mirrors in the cold darkness beyond Earth, it was designed to look deeper into space and further back in time than ever before. Scientists expected breathtaking images, clearer data, and refined answers to long-standing questions. And at first, that is exactly what appeared. Elegant spiral galaxies rotated like cosmic pinwheels. Nebulae glowed as stars were born and died in predictable cycles. The universe seemed vast, beautiful, and reassuringly consistent with the models scientists had spent decades building. But discovery rarely announces itself with dramatic fanfare. Sometimes it begins as a whisper hidden inside the data. Tiny irregularities began to appear in the measurements. Subtle distortions in ancient light. Slight changes in brightness that did not match expectations. At first, these anomalies were dismissed as background noise or calibration errors. Early data is always messy, and scientists are trained to be skeptical. But as more observations arrived, something unsettling happened. The irregularities did not disappear. They repeated. Noise is random. It does not organize itself. It does not form patterns that remain consistent across distances so vast that no connection should exist. Yet these signals did exactly that. For generations, humanity believed the universe unfolded without intention. Stars ignited, galaxies collided, and time marched forward under the steady influence of gravity. Everything felt mechanical, predictable, and indifferent. Now, the deeper we looked, the more that certainty began to soften. Some of the first surprises appeared within our own solar system. Neptune, the distant ice giant orbiting far from the Sun, began showing signs of rapid atmospheric cooling that exceeded every prediction. Even more puzzling, its magnetic field behaved irregularly, pulsing in ways that did not match known internal processes. It was as if the planet was responding to something beyond itself, something not yet understood. Beyond our solar system, attention turned to a compact planetary system orbiting a faint red star. Several rocky worlds circle this star in the narrow region where liquid water could exist. Observations revealed thick atmospheres rich in water vapor, suggesting vast oceans might lie beneath their cloud-covered skies. Even more intriguing were chemical signatures resembling ozone, a molecule that on Earth is closely tied to biological activity. No life had been detected, but the chemistry hovered near the boundary where life becomes possible. Then came an even deeper puzzle from the early universe. Light from some of the first galaxies appeared brighter and clearer than expected. According to long-standing theory, the young cosmos should have been filled with a dense fog of hydrogen gas that scattered and absorbed radiation. Instead, the ancient light traveled across billions of years with surprising clarity, as if the cosmic fog had lifted too early and too evenly. Scientists debated intensely. Perhaps the universe evolved faster than expected. Perhaps unknown processes shaped the transparency of early space. Every explanation solved one problem while creating another. As observations pushed further back in time, another strange discovery emerged. In a distant stellar graveyard, the remnant of a dead star still hosted a gas giant planet in stable orbit. According to standard models, the planet should have been destroyed when its star expanded and collapsed. Yet it remained, intact and inexplicably preserved. Meanwhile, icy moons in our solar system, once believed to be frozen and lifeless, revealed internal heat, subsurface oceans, and plumes of water erupting through their crusts. Even more surprising were the complex organic molecules found within their icy shells. These were not simple chemicals, but carbon-rich structures considered the building blocks of life. Were these molecules forming independently in isolated environments? Or were they being distributed across the solar system in ways we did not yet understand? Around the same time, a long-standing stellar mystery resurfaced. A distant star known for its unpredictable dimming was studied with unprecedented precision. Earlier theories blamed dust clouds or debris. New data hinted at something more structured, large objects passing in organized yet irregular intervals. Not proof of engineering. Not confirmation of anything artificial. But no longer easily explained as chaotic dust alone. None of this proves intention. None of it confirms extraordinary claims. Every idea remains under scrutiny. Scientific caution remains essential. And yet something irreversible has already happened. The universe no longer feels entirely silent. No longer entirely random. No longer entirely separate from the act of observing it. Instead, it feels dynamic, unfinished, still revealing its rules piece by piece. The deeper we look, the less certain the boundary becomes between what is being seen and what is doing the seeing. And within that uncertainty lies a question humanity has